Hey guys, welcome back. So today we've got an interesting one. This is a Briggs & Stratton Elite portable generator and comes to us from a subscriber, Eric, who I think has owned this since new. Unfortunately, he was not able to store this indoors. It was outside under cover, but given time, that got the better of it. Some rust did form in the cylinder and the engine locked up, so he took it apart. With a bit of elbow grease and some penetrating oil, he did get the engine to rotate, but only to be greeted by another problem, which he wasn't really equipped to deal with. So he offered this to us as a parts machine, which it might be, but of course I want to get this running again. So that is going to be the goal today. So let's get this off the trailer, we'll get it up on the lift, and I'll show you what he discovered. So to get the engine broken free, he did remove the head. He cleaned up the rust and let it soak in some penetrating oil. The engine did eventually start to rotate, so he put it back together, at least somewhat. I think it is assembled loosely, but what he discovered is that when he rotated the engine, the valves, they weren't moving. So likely there is a problem with the camshaft or some other internal damage. So I say we start there. Let's get these push rods installed. We'll try to adjust the clearance roughly to where it needs to be, and then we'll rotate the engine and see if either of the valves move. So I'm just setting the engine at top dead center, and a good rule of thumb is right when that magnet clears. If you rotate the flywheel clockwise, that's when the piston should be at the top, and you can see it right there. So we are at top dead center. And like that, the lifters should be down, so that'll make it a little easier to get the push rods in. And once they're in place, I'm going to adjust the valves so that we have zero valve lash, and then we'll rotate the engine and see what happens. So I'm just going to use a light to shine down and see the lifter. You want to make sure the push rod is on there, which it is now. And I've backed out the adjusters, so this push rod should go right in. But it's not. Actually, we're not even close. Let's see if we can do it with the valve open. And no, we can't. Even if I got it in, I couldn't adjust the valve because we're backed out all the way. So that's good news and bad news. That tells me that the camshaft is probably fine. I was thinking potentially it was broken or the lobes were worn out. But what I'm thinking now is that the camshaft pushed the lifters up and they didn't go back down. So, yeah, that's not a good sign. Although it just did go down. A lot of resistance, but now we can get that in there. We still have zero clearance, and this adjuster is pretty much all the way out. So let me try to push it down a little more. And now it's not going anymore, but we'll back off this adjuster. And that actually feels pretty good. So let me rotate the engine like this. I think the valve is going to open, but I guess the question is, will the lifter go back down? Okay, and it does go down. So the lifter was stuck, but the spring Seems to be enough to push it back down. So let's try the same here on the intake. Yeah, and like the exhaust, it is definitely up. And no, I can't get that one. Okay, it's in. And I think the spring may have just pushed it down. So let's adjust this to 0. Which we can't because the lifter is not fully down. So let me try to get that back in. We'll just push down on it. See if we can get it like we did on the exhaust. Yeah, there's no clearance right now, but let's just rotate the engine. Let's see if the valve will close after it opens. So yeah, it closed. Let me back off the lash a bit so that we have a little bit of clearance. Yeah, so right there, we have a little bit of clearance on each valve. So I might lock those down. And yeah, I'm thinking let's drain the oil. Let's make sure there's no water in there. Let's make sure we have oil. And if that's the case, I am going to rotate the engine at a higher speed and just see if these valves are functioning the way they should. Because the concern is if a lifter sticks and the piston comes up, we are going to bend a valve. So, leaving it like this might not be a good idea. And I think at a minimum, we are going to have to take the head off because I'm not sure if he put it together loosely or if he put it together with a new head gasket. So, we're going to have to go in and double check. And he also honed it with the piston in there. So, depending upon what I see, we might have to break this down anyway to hone the full length of the cylinder. Cap was on there, kind of loose. And yeah, there is oil. It's actually a little low. Still in the safe zone though, but I'm not liking the way it looks, although it's a little hard to tell, but it does seem a little bit milk chocolatey, which would indicate there is potentially some water in there. So yeah, let's be safe. Let's drain the oil. We'll put some known good oil in it before proceeding. Yeah, definitely water in there. It's coming out very thin, and you can just tell by the color. Quite a bit of water in there. So let's take a peek in there with the borescope. My concern is that the bottom end might be rusted up, kind of like the top end was. And we know the lifters are having problems. Although it looks pretty good in there. So those are the counterweights on the crankshaft. Usually those get rusted up when there's water in the system. You can kind of see one of the lobes on the camshaft on your left center, and that looks nice and clean. So, yeah, actually, the bottom end appears to be good. So we'll get this closed up. I'm just going to put some cheap oil in it for now, because we're going to have to, I think, flush this a couple times just to make sure, you know, all the moisture is out of it. So we get that oil in, and I'm thinking, you know, we should probably get some oil also by the rockers and the lifters just to help things out. And then I'm going to rotate the engine with a drill and just check the compression. So here's a close look at the oil that came out. It's pretty watered down. You can tell just by looking at it. The color is not right, and the consistency is not either. So we're actually pretty lucky that the bottom end looks as good as it does. And we'll also get a little bit of Marvel mystery oil in the top end. You know, when I rotate the engine, I'm not sure if it feels quite right. Like there might be a little bit of drag. So, you know, that is concerning. But I'm hoping once we get it fired up that maybe it'll work itself out. So I'm going to rotate the engine without the spark plug in there for now. I don't want compression fighting me. I just want to get some speed in the engine so the oil gets flung around. We'll just loosen things up a bit. I'm going to do a quick and dirty valve adjustment here. It should be 5/1000ths of an inch, plus or minus 1/1000th. But I'm not going to spend too much time on it, because regardless of what the compression test shows, you know, I'm going to take the head off at least and verify the condition of the cylinder. You know, I don't know if these bolts are torqued properly, and I don't know if there's a new head gasket in there. Close enough. It's a little bit big, but only just. Okay, that's pretty good right there. Okay, that should be good. Quick and dirty test. Just rotate the engine with your thumb on the spark plug hole. And we definitely have compression. So, you know, this has a decompression system. You know, we should see about 60 PSI plus or minus about 10. So let's see where this one's at. I'm not too sure my drill is going to have enough power to rotate the engine, but I'm hoping with that decompression system it'll be enough to get a few good revolutions. Beautiful. We're at about 60 PSI, which is exactly where it should be. So this engine will run. So let's get the head off, make sure things are in order. Then I think we need to put it together and try to fire it up. So I'm going to get the carb and the exhaust off, as well as this heat shield, and then we'll have access to all the head bolts. Yeah, these are not torqued, which is fine. I think he said he just put it together loosely. Not great. So you can see up above and kind of on the sides, there is a ring going around. You know, that is likely where the piston was, and the rings kind of rusted to the bore. What's really concerning, though, is down here. That mark near the top on the bottom, that can be felt. You know, that is pitting. And like that, although we have compression, you know, I think there's going to be a lot of blow-by and probably increased oil consumption. So, you know, I don't think honing is going to fix that, but I do have a small hone. I'm going to run it through there right now just for maybe a minute and see if that cleans up at all. It's kind of too bad too, because this engine, like I probably alluded to earlier, it's a good engine. This one has an oil sensor, and the bore, it is steel. You know, the newer version of this engine, it's actually an aluminum bore. And in this case, an aluminum bore probably would have saved this engine. But I'm not giving up yet. And the correct way is to pull the piston, which we might do. I just want to see if there's any chance. Yeah, it's a little bit better, but still not great. It's very rough. It is pitted, and it's not the only spot. There's actually other rough spots kind of all around the cylinder here. So, you know, if I put a new head gasket on here, would this run? It would, but it would consume oil. It would smoke. Likely it would be down on horsepower. So the right way to rebuild this would be to get this bored out, probably 30 over. New piston, new rings, new gaskets, and for about $150, maybe $200, you know, this engine could be made right. That said, though, I've already rebuilt 2 of these engines, and they're just sitting on a shelf waiting to get some action. And I think today might be the day. So this is the engine here that I'm going to use. I actually rebuilt this on video about 1.5 years ago. This one locked up due to a lack of oil. This is the newer version of that engine. It has no oil sensor. It has an aluminum bore, but it is fully rebuilt. It runs well. And I guess the only reservation I have on this one is that when the connecting rod broke, it did chip a piece out of the bottom of the cylinder. You know, it's not in the ring travel, so likely it'll be fine. But this one, it's not perfect either, but it is a lot better than what's on there now. So let's get the generator off. We'll get the engine out, drop this one in its place, and I think we'll be in business. And I guess regardless of what I decide to do with this engine, you know, even if it is a parts engine, there's a lot of good parts here. You know, the ignition coil, I can definitely use. These wires I use all the time. The governor spring, that's discontinued, so it's good to have an extra one of those. And the oil module and the switch inside the engine, they are discontinued. So, you know, stuff like that, even the connecting rod, can all be put to use. You know, ultimately, we're kind of battling costs with this because, you know, this generator up and running with a good engine and a good generator in my area would only sell for about $300, maybe $350. And if you have to spend $200 just to get the engine fixed right, that leaves very little profit. But instead, you can turn something like this into basically a tool to fix other machines at minimal cost. So yeah, I'm not committing either way, but I'm just saying it doesn't always make sense to rebuild, especially when you have other options. So I just had a thought. It may not be a good one, but here it is. You know, this engine, when I take it off this frame, I am going to put it back together. You know, I want to make sure I have all the parts. I want to keep the parts together. And if I'm going to do that anyway, I might as well do it now. You know, we'll put it together as is with the parts on hand. And I'm thinking, let's fire this engine up, at least for a minute. You know, I want to hear it run. I want to make sure we don't have rod knock. We can also validate the health of the generator. Plus, there is a bit of moisture still in that engine. So getting some heat in there is not a bad thing. I think it's only going to help it out. So let's get the engine back together. We'll test it out for a minute or so, and then we'll do the engine swap. So needless to say, this is not the right way to rebuild an engine. This is more a will it run. If you want to see how to rebuild this engine properly, check out the video rebuilding that other engine, the one that's eventually going to go in here. And hopefully in the future, there will be a rebuild video on this. And actually, if anyone watching has the equipment to bore this properly, let me know. You know, I'll be happy to send you the short block. We'll get this bored. Actually, 20 over is the largest we can do. And then we can properly rebuild this. It should be torqued to 220 inch-pounds. So I'm going to bring it up halfway first to about 100. And then we'll finish it off. Although, in this case, it's not going to matter too much because this head gasket being used like it is isn't going to last very long. And we do need to double check the valves. You know, last time the head wasn't torqued. So the exhaust is tight. Intake might be loose. Yeah, 6 fits in there without issue. And the exhaust actually isn't bad. 4 fits. And a 5 actually has the right amount of drag. So let's close up the intake just a bit. Five feels pretty good. And a 6 doesn't fit. So the valves, they are right where they need to be. So let's get a little bit of oil on everything. And then we can close this up. And according to the date code on the valve cover, this was built April of 2006. So just under 20 years old. And I think the last year they had the oil sensor. It's interesting too, this blower housing is silver. Never seen one this color. So I'm actually going to pull off this governor rod. This is the proper one for this machine. But I'm noticing there is a difference between the governor rods on this machine and the rebuilt one. And I want to use the carburetor from the rebuilt engine because I know that carb is good, and I'm pretty sure the carb that was on here needs to be rebuilt as well. So the difference is on the carburetor side. You can see this one goes straight down, whereas the other one is curved. So not a huge difference, but it does make a difference as to whether we can use the other carb or not. And let's just double check the calibration. If the governor rod isn't the same length, then you would actually have to reset the governor to have control of the engine speed. So right now, the spring, it's holding this in wide open throttle. So if I move the throttle plate in the same position and align this, they should align at least within about 1/8 of an inch. And in this case, we're right there. So that should be fine. So we'll lock that in. insert the other stud. And we'll torque this down and connect that anti-surge spring. Well, for better or worse, it is back together. We are fueled up, and theoretically, this should run. And I think you're going to be a little bit surprised because I think it's going to run better than, I was leading on to. That said, though, we will kind of keep an eye on the breather. I'm expecting to see some blow-by given the condition of the cylinder. Likely the rings are stuck as well. But let's give it a pull, see if it starts, and if it does, we'll check out the power output. Well, on the surface, it seems like the engine is good. You'd never know what the cylinder looks like or that we had a used head gasket in there because it started first pull. It sounded really good, and the generator is working. That light turned on. We're at 131 volts, about 62 hertz. And even the breather, I didn't see any signs of excessive blow-by. That said, though, we weren't under load. So I'm thinking, let's try this one more time. I am going to refuel, but this time we'll bring out a space heater or two and make the engine work. See if that makes any difference. All right, we are refueled. I also extended the fuel line so we can get a little more runtime out of it. And of course, this time we have a 3,000 watt load. So let's get the engine restarted. We'll make the engine work and see if there's any signs of a problem. It's really pretty surprising. I didn't see any signs of blow-by on this engine, which is really surprising given the condition of that cylinder. So yeah, I mean, could you use this engine? I'm sure you could, but I do have two that are better. So regardless, this engine's coming off and a rebuilt one going in its place. And just keep in mind, these brushes, you can plug the wires in either way, but you have to have the tab facing in because these are polarity sensitive. And if you do it backwards, the generator's not going to power up. And this one's pretty easy. Usually generators have a wire block that you have to disconnect the wires. In this case, we have this quick disconnect. And there's also one up above on the control panel. But let's disconnect it down here. And then really we'll be in a good state to get this off. All we need to do is remove the bolts, detach the stator from the frame. And we should be able to use a puller to pull the stator off that ball bearing. Yeah, I think we're going to have to remove these as well because we don't have enough clearance actually to get the stator off like it is right now. So these are just threaded in to the end housing. So they're easy enough to get out of the way. And then we need to lower the stator back pretty close to the rail so that we have some clearance. And this stator, it's different than most. Usually I would just remove these 4 bolts and then the end housing and the stator would come off as one piece. And technically you could do that, except the end housing would separate from the stator and then you're left with the bell housing right here. But this is actually in 2 pieces. So if you remove these 4 bolts, this will actually split in half and you don't need to remove those bolts. I'm just going to use a bit of PB Blaster, which might help a bit. We need to free the ball bearing, and to do that we are going to use a puller, and we're not going to pull actually where the brushes go because that's really thin and this aluminum breaks easy. So we'll pull on the top and bottom, and we might have to strike the bell housing with a dead blow hammer because there is a lot of corrosion, so those 2 parts might need a little help separating. it's coming. No need to hit it with the hammer. I guess what I should have said is no need to hit the bell housing with the dead blow hammer, but we do need to strike with a 3-pound hammer on the end of this bolt. So that is a 8mm bolt. It's pretty easy to pretzel. So I turned it all the way in and then backed it out 1 turn. You know, I don't want to have too much in there to collapse and potentially get that bolt stuck in the shaft of the rotor. Yeah, the hard part's done. We have the generator off and got it off without causing any damage. That said though, we still need the bell housing. It's held on just by 4 bolts, but they are Loctited in. So I am gonna apply a bit of heat to each of these to help break them free, and then we'll hit it with the impact. I decided to take a quick look at the oil. I was kind of curious to see if it picked up any more water. You know, this was fresh oil we put in there, and I think you can tell it turned into a milkshake. So yeah, it's probably a good thing that we did get this engine running to help get some of that water out of there. So I will drain this again and probably start it again before putting it away in storage. There we go. They are on there pretty tight. All right, let's get this engine fired back up. We are refueled, we have fresh oil, and the engine is reasonably secured. So we'll get it going, run it for a minute or so, and then check back on the oil. And yeah, we have a milkshake again. So this is going to take a few times, but I do want to get this oil cleaned up before getting this in storage. So I'm not going to bore you with it. It's probably going to take 2 or 3 more oil changes. But yeah, let's get the oil out again, and we'll do this again. So I don't think I'm going to torture you guys by watching this process. It's going to take a while. You know, we had the initial oil change with the oil that was in there, plus the 2 that we've done since getting the machine. And, you know, it's getting a little better, but still, obviously, we have a ways to go. So, you know, I'm thinking I'm going to have to do this a couple more times. So I will just skip ahead and kind of show you the end result here. I think I'm going to call that for the win. It only took 1 more oil change, and it's finally coming out kind of looking like oil. So I've already refilled. I'm just going to take a second to clean up my mess, and then we'll get this engine off and put the rebuilt one in its place. So I've already swapped the carb back. This is the one we were using on the other engine. So we just got to get the airbox on. And then we have to make an adjustment, I think, on the governor. When I rebuilt this engine, I moved the governor spring to slow the engine down. And it's currently in that position. So we're going to move it back to where it originally was, so that when we start this, it should run at about 61.5 Hertz. And we're going to stick with the original airbox cover. This originally had one that said storm responder on it. So this spring originally was in the position E, and moving it in like I did, that just took some of the spring tension off. So we'll put that back to the original spot right there. So next we'll get the bell housing on. The bolts, they were pretty caked up with thread locker. It was actually the red variety, which is why it was so hard to remove these bolts. So I'm going to put them back with some blue. That should be good enough, I think. Make sure the tab goes in. Yeah, at this point, we're pretty much done. We just need to add the heat shield and the fuel tank. But before I do that, I do want to hear the engine run. So I am going to fuel this up. But even before I do that, I do want to rotate the engine a few times. I want to make sure that the alignment between the stator and the rotor are good, that the engine rotates without issue, and that I don't hear any contact between the stator and the rotor. I think we're looking pretty good. It started first pull, the engine sounded good, and the light turned on. So I say we finish it up. Let's get the heat shield on as well as the tank, and then we'll roll this outside and see what it can do. So it's actually been about 2 months since I fixed this. It was a very cold day in February, and now it is an absolutely beautiful day out. So I'm curious to see if it still starts first pull. And of course, I want to find out if it can pull its max load of 550 watts. So to do that, we are going to use the load bank. We also have the kilowatt to measure the voltage and the hertz. And the amp probe will tell us the total harmonic distortion, and the oscilloscope will give us a look at the sine wave. Now, I'm sure this engine can pull its rated load, but it has been rebuilt recently. It has a new set of rings. The cylinder was honed as well. And technically, this is not broken in. I've only run this for about an hour, so the engine may not be quite up to the task, but I'm willing to bet it can do it. So let's get the engine started and find out how it does. No issues at all getting this machine started. Started right up, first pull, the engine sounds good. So without a load, we are starting at about 8.1% total harmonic distortion. And the sine wave looks pretty typical for a machine like this. So let's start with a 2,500 watt load. So we'll put on 2,000 watts, engine speed's holding fine. And now we're at 2,500 watts, so no issues at all. The engine's handling it just fine. The total harmonic distortion actually didn't change a whole lot. We're at 8.6%, and the sine wave cleaned up just a bit. So we'll give this a few minutes. Assuming it goes well, we'll go for the max. Well, it's been a few minutes and absolutely no issues pulling 2,500 watts. So let's bring the load up. I'm going to swap the 500 for a 2,000. So now we're at 4,000 watts, 5,000, 5,500. No issues at all. The voltage is holding. Engine speed as well. We're at about 60 Hertz. And the total harmonic distortion isn't that bad. We're at 13.6%. And the sine wave looks largely unchanged. So usually I would keep this load on for a while, but given the engine isn't properly broken in, I think it would be best to take the load off. And we'll give it a few minutes for the load bank to cool down, as well as the engine. Well, this machine, it just performed flawlessly. It had no issues pulling its rated load, which is kind of surprising, actually, given the fact that this engine is not fully broken in. And I think even more surprising was how well the original engine ran. You know, given the condition of the cylinder, the fact that the lifters were stuck, and we were reusing a head gasket, it actually performed quite well and likely could have run like that for years. But given the condition of it, you know, it's definitely not going to last forever and should be rebuilt. So that is something I hope to do in the future. But for now, we've got a good running machine and one that I know will last a long time. So I hope this video helps someone. Thanks for watching.